Welcome all the students to object-oriented programming. Oops, inheritance in Python. But before we start with inheritance, I would just like to give you an overview of what we had learned in the previous class. So what we learned in the previous class is as follows. We learned instance variables, we learned class variables, instance methods, class methods, static methods, and even now if you want the definition, for example, if you want the complete definition of class method, static method, I always update and upload all the descriptions and the definitions right with the video. You can find the description, or you can find each and everything theoretical related to that current topic down in the description section. So I'll give you an overview of description, how can you find it, and you can clearly see here instance method. So this is the description of the video, which is part number 27. So you can clearly see the description right here in this Python object-oriented tutorial. Now you can see this here. Instance methods are the most common type of methods in Python class. Instance methods must have a self as a parameter. That means that instance method use self as a parameter because they are created inside a function or a constructor, most probably a constructor, right? Static methods in Python are extremely similar to Python class level methods. Both are called without creating an object of the class, right? And this is the class method, decorator, and each and everything you can find down in the description section, right? So I always update video. After posting the video, I always update it with the description, right? I always define each and everything, right? So do not forget to check the description henceforth, right? Okay. Let's get started today. So now we are done with this. Now can we go back and see classes and objects are done, right? Class is a template, a user-defined prototype for user-defined. Okay, we know that. And attributes are the variables and the functions of the class or the methods of the class. So that's also defined. What's an object? It's an instance of the class, right? Test is, now for example, if I create an object, I'll say t is equal to test. So we create an object of the class. So that's already defined. Class variables and instance variables is also done. Object is done. And now encapsulation is almost done, but yeah, I will just skip it. I'll start with inheritance. As promised, we are going to start with inheritance in the real world. And before I start with the inheritance, right, I would like to show you something. Now can we create a class inside a class, and then we'll go with inheritance, right? So that's a very important topic of Python, and it's very interesting, right? Can we create class inside a class? So for example, I have a class student. So I'm creating a class student, and I will create a constructor. So I'm defining a zero parameter, no, not a zero parameter. I'll define a parameterized constructor. Now this is the constructor. So this is the first thing to be called when you create an instance or the object of the class. Self is the ruling for Python. It actually means the object, right? And we have name and we have roll number, all right? Alright, now so I will say self dot name. Now I'm declaring an instance variable and I'm initializing. Now this is called instance variable declaration, and this is called instance variable initialization. The moment I declare it, I'm initializing it with this name, alright? And same I shall do with the roll number. I'm doing the same with the roll number, right? Okay. Alright, fine. So I'll say save this as classes. Okay, so now this is called instance variable declaration, and this is called initialization. You may call it as definition, right? So definition can also be very good. So this is variable declaration, this is variable definition. So you're defining and declaring a variable at the same time. Okay. Now we have define, let's say about I'll create a method known as show, and it's not going to accept any parameters, but since it's going to deal with the instance variable, because if in case you want this method to deal with instance variable, you have to pass self. Then and only then, with the help of this self, you can call instance variables, right? The self is nothing but this. It is basically a paradigm for this. It's an alternate for this. Right? In other programming languages, we say this. What does this mean? This means this class or within this class. So this is not available in Python. Instead of this, we have this self, which actually means an object of this class, right? Now, so if you are dealing with instance variable, then you have to, right, accept self as an argument here. That will be automatically passed. So I'll say display will do nothing. It will do self dot name. It's going to print self dot name, and it is going to print let's say about self dot roll number, right? So that's what show is going to do, right? And now if I call this, I'll say s equals new student. So this is going to be a new of student, means object of student, and then case s dot show, right? So now you will get it. I know, so there's nothing wrong in it. So now once you make an object of the student or an instance of the student, if you are accepting two parameters, please pass two parameters. So I'll pass 100 and let's say about Naveed. So I'm passing two parameters in here. So now you're getting 100 and Naveed. So absolutely perfectly all right. So there's no problem at all. Right? Do you have any problem? No, it has no problem at all. So now what I want is the following. So let me delete this. So can I create a class inside a class? So now this is class, and now I'll go one step or maybe two steps inside the class, and I create class laptop. Now this means it is as if I'm creating a class inside a class. So I'll say define. So double underscore, I'll say init double underscore, and no arguments are accepted but self. Right. All right. So now I'm declaring some instance variables. I'll say self dot. So I'll say self dot brand is equivalent to, let's say about HP. I'm just initializing them automatically. So I'll say self dot CPU configuration of the system, because the once the name of the class is laptop, and attributes can be configuration. So the CPU is i7, or we can say core i7. What's core? It's core i7, and I can say self dot RAM, right? And that RAM is going to be, let's say about 8, right? So what is 8? 8 is maybe 8 GB. So right. Okay, now can I make an instance here of these things, right? Now because I have a class inside a class, so let me make a class instance, right? So I will say s1 is equivalent to student. So we have to pass Naveed, and let's say about he has row number 101, and I'll say s2 equals student. Call student again. Another instance of the student is going to be created. Pass Fahim and say it is going to be 100, right? So whatever. So now you may run it, and okay, we have this problem right here. Why do we have this problem? Okay, now what? Okay, so we are not calling. Yeah, it's absolutely right. So now can I do this s1, which is the object of student, right? And can I do this dot? I will create lap. So we can create this object of laptop as well, right, in here. All right. So now I want to access it. Now how can you access it? Now you can see this is the constructor right here, and this constructor belongs to class student. Now look at the magic here. I'll go inside this constructor and I will say self.lap. So I'll just create an instance variable. I'm creating an instance variable, right, and I am dropping self dot. Now see the magic. Now you can see self dot laptop is also available right here. Now another class, it's a class inside a class. I repeat, class inside a class. Now this class laptop, right, is basically being initialized inside student class. That's why I'm calling self.laptop. Why? Because it's in this class. You may not use self for anything which is outside the class. Self is used only for the things which is inside the class. Self means this means inside this class. Right? So now this laptop is inside this class. Now can I do something like this? s1.lap dot brand. So now can I do this, right? So let me see, or maybe I'll print it. I am getting HP. I did not create an object of laptop. I did not create an instance of laptop, did I? No, I did not create an instance. I'm creating instance of student class, right? And I'm declaring this laptop class inside this student class, and this class has its own constructor and this has its own constructor. So now if I create something like this, so I will say self.laptop is there, so you can use print or let me just go here and say let me s1.lap.brand, right? So you can also use this lap1. You can see, for example, you have to create two objects, so I can say lap1 is equivalent to, so I don't have to print anything, so I'll say lap1 is equivalent to s1, which is an object dot lab. So this is how you can create object also if you want to call, right? And then you can say print lap1 dot, or you can say you can get ram, right? Or you can print all. I mean, you can say, you can format it, right? The lap brand is, and then you can use it here, lap1 dot bran, the brand, right? And the let's say CPU is, and then you can use the same here, which is lap1.cpu, right? So on and so forth. You can use anything. The brand is HP and the CPU is Core i7. So this is how we have successfully created a class inside a class. Can we create a different object? Yes, we can create a different object as well. For example, if you want to see an ID of both of them, right? Let me go ahead and print for your information whether the object is same or it's a different object. So I'll print ID of let's create two objects, lap1, and let us create second object as lap2, right? So let me go ahead and define lap1, right, is equal to s1, which is the object of student dot lap. All right, you can create it like this, okay, and you can see lap2 is going to be, right, s2 dot lap. Now s2 has student Fahim, and because there are two different instances, s1 is an instance of student class, right, but a completely different instance, because here we are passing Naveed and 101, here we are passing, right? So this means actually new. You're creating a new instance. Whenever you call this means new instance, right? So whenever you say S1 has been assigned with student, it's a new instance of class. A new memory is allocated every time you call this. You make an instance of the object here, a new memory is allocated, and here also a new memory is allocated. So this means creating a new instance, or we can say creating a new object of the class, right? So now here we are printing, now since we are now with an object of class laptop, we're calling class, sorry, with an object of class student, we're calling class laptop, with an object of class student, we are calling class laptop. Now we are saying lab1 and lab2, whether they have similar or different IDs. Now you can see that they too have different IDs. That doesn't mean, that means they are using different memory allocations. Right, so that means that is why we are creating different objects. Right, you can create objects of inner class inside the outer class. Yes, we can create objects of inner class outside the outer class, provide you, I mean, unless you know what your goal is or what you want. Right, for example, we have this class. Let me go ahead now. Did you get this? Yeah, object is created differently, right? So we always create different objects. So I can go ahead and say, hey, I'm calling s1.show. So when I call s1.show, where is show? Show is going to print the name, and you can see now it's printing Naveed and 101. I can say s2.show. All right. So now that's also possible. All right. Now can I call it directly? Now I can call it directly without even calling the object. Right. Now you can see this here. All right. I'll say lap1, which is laptop1, is equal to the name of the class is student, and I can call laptop directly without any object. So here I'm not using any object, I'm just directly calling it. So that means we are creating an object of the inner class outside the outer class, right? That is why we have to. But yeah, if you want to call inner class, you have to call the outer class first. So that means you have to use the name of the outer class. Now, which is the outer class? Student. Which is the inner class? Laptop. So you have to first call the outer class in order to call the inner class without the object or the name. Right? We tried two different things. We said s1 is equal to, so let me get rid of this. So I'll just show you this here. There are two ways of calling. I said s1 is equal to student. So now the moment I call student in here, I have to pass two parameters because this constructor belongs to the class student. So now I will pass two parameters in here. So I will pass parameter number 1 as Fahim and 10100 as roll number. So what is happening here? So first I am making an instance right here of, or we can say object of s1. So I can use the same object to call the function. Yeah, I can use dot show, right? So now if I can use the object to call this function in here, and I can see that Fahim and 100, so you're getting it, no problem. So if I'm using this object to call show, can I use the same object to call the laptop? Right, we can use, no problem. But what inside laptop? I have to use these variables, right? So I have to create a new instance. So that's why I said lap is equal to s1.laptop. So s1.laptop has been initialized as lap, right? So number one, in order to initialize the outer inner class, we need the object of inner class. So I can say now print, right, lap dot brand. So here we can easily get right the laptop dot y. Okay, s1 dot laptop. It should have laptop dot brand, so we can easily print it. Why not? We are creating lap dot brand. So let me go underneath it first because we are initializing the class here. Okay, so let me go underneath in here just to do the rest of the things. Okay, yeah, okay. So now where were we? So I said I'm initializing s1, and then I say lap1 is equal to s1 dot laptop. Then I go to laptop dot brand and I initialize it. It has no attribute brand. What happened? Something wrong has happened just now. I don't know. I have no idea. Alright, so I can say lap1 is equal to s1 dot laptop, right? Or you can say we have to create it s1 dot lap. Why? Okay, I have basically created lab, that's LAP lab, so that's why it's creating confusion, right? So we have to call lab instead of laptop, because that is where we have created this, right, instance of laptop, right? Okay, now you can clearly see. Okay, I'll show you where I showed you earlier, because it's quite visible here. That's why I'm showing you, though it should not come here, but yeah. So now you can see we create an instance, and now we say print lab dot brand. So you don't have to create an instance of lab is equivalent to s1 dot laptop. So I'll say it is going to be s1 dot lab. Why? Because we are creating an instance. What we can say, we are creating this instance and giving it to self dot lab here. Right? So when you call student, it already has self dot lab right here, which is having an instance of self dot laptop. That means it is the constructor of the inner class is having the instance of the constructor of the outer class. So now you can see it's going to work HP. You're getting it, right? So that's not what I wanted to say. I say we can create, right, an object. We can call the inner class by the object of the outer class. So now this is the object of the outer class, and we're calling the inner class. Or I said I can, without even this, I can create and call it directly. But yeah, to call the inner class, you have to use the name of the outer class. So that's what I said. You can call it directly. For example, I'll say lab1 is equivalent to student. Now you can see is equal to student dot laptop, right? Now you can say lab1 dot brand has to be printed, right? Why are we getting this kind of error? So let me take it again here after the class. Fine, let me print. So now you can use it directly. Now you can see that, yeah, instance has been created. So lab1 is equivalent to student dot laptop. But yeah, because you're calling a class now, you can directly call the constructor of. That means this is the inner class. Sorry, this is the main class, outer class student. You are using the name of the outer class to call the inner class. But here you're not calling the constructor of student class, but you're calling the constructor of laptop class, which is the inner class, and it does not accept any arguments. Now you can say print lab1 dot. Now you can see you're getting brand, you're getting each and everything. Now you're printing HP. Now this is all about inner class, and this is all about outer class. So this is how we are going to handle inner classes, and this is how we are going to handle outer class. Now if you want to print the student data as well as the laptop data, so you say, sir, I want to print the student data and I want to print the laptop data as well. So now I can go inside here. So I can create, let's say about so I will, so I'll create another function in here. So I'll say define. This function belongs to laptop, so I'll say show. Now this show function is as that of laptop now, not the show belongs to student, this show belongs to laptop. So now I'll use the same function. So I'll say, hey, you mind if you print, let's say about, so print self dot brand, or you can say you are going to print self dot brand, self dot CPU, right, self dot let's about RAM. Sorry. So now this is going to print brand, CPU, and RAM. This is going to print also. This show belongs to the laptop class, and this show belongs to the student class. What is this show? This is the method of student class. What is this show? It's a method of laptop class, right? What is laptop? It is the inner class of student class. What is student? It is the main class which has attributes, functions, and also a class, right? Now if I want to print both, right, either I can call it differently. For example, now if I make an object, let's say about like let's say about if I'm making an object like this, let's say about I say lab1 is equivalent to student dot lap, right? And then I say print, or we can say lap1 dot show. All right, so I call lap1 dot show. The moment I call, oh my god, right? So lap is there. Yeah, student.lap is there. So lap1 is equal to student. It's not student s1 dot lap because you have to use the object here. Right, so you're getting HP Core i7 and i8. What if I want to print both of them, right? So then in that way you can say, write s1 dot, let's say about show. So now this show is student and this is for the laptops. It's as simple as anything. Fahim, and this is my roll number, and this is what I'm printing. Now if you do not want to call the functions twice, you want to call only one show, and that show should call the another show. Right, now you can call this here. This is the show function or show method of student. Right, you can go here and say, hey, I want to call self.lap. What is self.lap? It has an instance of self.laptop, right? And you can call self.lap has show. Right, so now you're calling self.lap means self.laptop. It has a function show. You're calling that show. Now here what you are doing, you are calling only s1 dot show. So when you call s1, which is an instance of student, it has a show function. It's going to call the show of the laptop as well. Now you can see, right, both are being printed. So this is how you create inner and outer classes and how you manipulate with inner and outer classes in Python. It's a very good feature, very good feature, right? All right, now this thing is done. So let us go and start with inheritance in Python. So I'll say, now what is inheritance? You might have heard the word genetic, right? Genetic means that you're getting from the parent, right? Maybe your father had let's say about had a small nose, and now you're also having a small nose. I may come up to you and say that, hey brother, you inherited your nose from your father. That means you have inherited a property which is a nose property of your father. That means something which is with the father is with the child. That is what inheritance is all about, right? Now, does Python support inheritance? It absolutely supports inheritance, right? And does it support multiple inheritance or single inheritance? Only the time will tell about inheritances, right? So let me show you a very small demonstration of inheritance in Python. Right, so let's carry on with inheritance in Python. For example, I have a class A, right, and it has a function feature, right? I'll use just plain self. This self means I'm not accepting any object. If I have to accept any not the object, sorry, if I have to accept any argument, so then I have to define that argument in order to define, right, in order to accept that. So I have to basically define. For example, if I have to accept name, so I'll define it here. So just by calling self doesn't mean you're accepting any argument, so you're not actually. So you can say print feature 1 is working, right? So now this is the class 1, feature 1 is working. Okay, now how many features does class A have? Right, would you please tell me? How many features does class A have? Class A has, let's say about feature number 1, and it has feature number 2, right? Feature number 1 and feature number 2. So can we say that class A has 2 features? I'll say yes, class A has 2 features. So let me go and create class B. So it's not a class inside class, it's a different class. Class A here is a different class, and class B here is a different class, right? So now I'll define class B, right? And let me say class B has few more features, right? So class B has more features. Let's say about class B has feature 3 and feature 4. Alright. Okay, feature 3 is working, feature 4 is working, as simple as anything. Now if I have to create an object, if I want let's say about these features, I'll say C1 is equivalent to class is equivalent to A. So I'm making an instance of A, right, and I can say print, right, let's say about C1 dot feature 1, and I'll say C1 dot feature 2. So that's absolutely alright. So I'll say INHERITANC. I'll say this as inheritance. Alright, so you're creating C1 is equivalent to A, you're creating an object of class A. C1 dot feature 1, okay, it already prints, so you don't have to call print. So I'll just call them separately. I'll say C1 dot feature, right? Okay, so I'll say C1 dot feature 1 and C1 dot feature 2. Right? Why didn't I print? Because I'm already using print. When I call C1, which is an object of class A, I say C1 dot feature 1, which is this function. It is going to print feature 1 is working, and this is going to print feature 2 is working. So let me see, what are we getting here, right? So we're getting feature C1 is equivalent to A, right? We should get, but we're not getting it. What is wrong? Class B has feature 3 and it has feature 4, so I don't know, A1. So is it class A1 is equal to feature 1, so it's not going to do anything, but yeah, why aren't we printing the feature 1 in class 1? We should get feature 1. Feature 1 is working, should print, right? Isn't it? I don't know. My spider is behaving something. I don't know. It's a weird behavior at times, right? So let me open ideal. Let me go to ideally and see what can be done. Alright, so I'll use the same here, inheritance. Say this as inheritance. I don't know if I run this. Say, yeah, I still not get anything here. So that means problem is not with the spider. Problem is with our code. A1 is equivalent to A. That's absolutely fine. You're creating an object of class A, and then you're calling A1 dot feature 1, which in turn is going to print something for you, right? So if I say ABC is the class name, so what do ABC is the class name, when it prints, it's still not printing anything. My good God, I don't know, something is pretty wrong here. Right, so let me just delete all. I don't know, something is wrong, so let's say class A, right, and it has a function, or it has a method. Class can never have a function. Class can have methods, as I said. Feature 1, right, and self. So I can say print. It's as simple as anything, right? FEATURE 1 is working. So that's what I said, and then I say A1 equals, right, A. So I'm making an instance of class A, and I say A1 dot feature 1. I call feature 1. So now we're getting feature 1 is working. What was wrong earlier? So let me just control Z. Okay, what is wrong? Oh my God, feature 1 is a function. Yeah, Feature 1 is a function and feature 2 is a function, and we cannot call function without parentheses. Alright, so my. Alright, so I'm maybe feeling pretty hungry today because of fast, so I cannot see that it requires parentheses. So are you maybe? Okay, now we're getting feature 1 is working and feature 2 is working. 2 TWO2. Alright, so feature 1 is working and feature 2. So you'll say, sir, what are you showing us? We already know this. Yes, you know this. But what if I say that I want feature 3 and feature 4 as well? So I have to create an object of, let's say it's not ABC, it's A only. So do I have to create an object of class B as well? Right? Yes, that is what you have to do. So you will say B, or let's say A and B. So I'll say A. Now, what if I require feature 1 is working, feature 2 is what is I require feature 3 and feature 4? That means I can either use this or I can either use this. For example, now I'll go to B and I'll say B dot feature 3, don't forget parentheses here, B dot feature 4. So in order, if you want to use them in a single line like this, right, if you want to use them in a single line like this, it's going to create an error, right? You can see, because you have to end the statement. So you can terminate the statement like this here, and you can terminate the statement like in order to, only if you're using it in a single line. So that's why you can save some space right here by using terminator. You can call it in a single line. Now we have feature 1 is working, feature 2 is also working, feature 3 is also working, and feature 4 is also working. But that is calling different objects, right? So if I print the ID of A and I print the ID of B, are two different objects. Now this is not going to suffice us because I want this to be parent and this to be the child. That means class B should inherit the properties of A. Class B, I want to make class B as the children, or sorry, as the child of class A. Now how do you do that, right? So just let me go ahead and just not have, I'll only have B, right? Let me have the object of B only. So now I want B to inherit all the properties of A. So now what I do is A. So now this bracket here means that B is now going to inherit all the properties of class A. Now if I say, hey, I want B dot feature 1. Now you can see you don't have to make an object of class A now. You can use B also, B dot feature 2. Feature 1 and feature 2 is not of class B, it's of class A. But yeah, because class B has inherited all the properties of class A, class B has inherited. Now class B is basically a derived class or a subclass, and class A is a derived class. Although it's basically class A is a called class and class B is a calling class, right? Or you can say that basically the base class is A, right, and the subclass is B. Okay, now B does not have feature 1, but you said you're creating an object of B, right, and you're using the instance of B to call feature 1, using an instance of B to call feature 2, which is basically a property, or we can say which is basically a method of class A, right? That is because of inheritance. Now you can use B dot feature 3 and B dot feature 4. Now do you expect an error here? Please expect an error. Why? Because you're using single line statement, right? So if you want to use single line, so then you can terminate them like this. This is called terminating. Now how does it know the second line is starting, right? The second statement is starting only by termination, and termination is not required in order if you go to the next line. If you're going to the next line, so that then the terminator is not required. Next line is going to be treated as the termination. Now you can see here the line ends, and now you don't require terminator here. Now you can see right, it's working. Feature 1 is working, feature 2 is working, feature 3 is working, and feature 4 is also working, right? So this is inheritance for you. What time is it? We still have good amount of time, so we can continue with the inheritance, right? And we have many different things. Now does Python support multiple inheritances? For example, if I have class C, right, and the class C has let's say about now some features. Let me copy and paste them. Now in case we're having class C now, right, and class C has some features, let's say about okay, let me take this class, let me keep them in a queue. First we have A, then we have B, and then we have C. All right, okay, now feature 5, feature 1 is working, feature 2 is working. Okay, I'm going to say feature 5 is working and feature 6 is also working. Now can I make sure that B inherits A comma B? Is it possible? Yes, it is possible. Maybe, let us see. If I go, I will say B dot, you can see we're getting only 4, 1, 2, 3 and 4. Alright, 5 and 6 is not here. Right, you can clearly see, but you're inheriting, you're saying, hey, B and A and B, but you have to say A and C in order to inherit from the C. That's the magic here. Now I'll say B dot feature 5, and I can say B dot feature 6. And Python is the only scripting language. Java does not support multiple inheritances. C# does not support multiple inheritances here. Now you can clearly see right here. Feature 1 is working, 2, 3, 4, 5 and 6 is also working. What error is this? Undefined name C, because C has to be defined here so that it gets the name. Alright, so now you can see that we are doing multiple inheritances, right? So that is, or we can do something like this. So let's keep C here. Let not B inherit anything. Let the C inherit both A and B. So C is inheriting from the class A and class B. Now I will say B is equivalent to new C. Right, so we can, or we can keep it B, or no, it's going to create a confusion. So now multiple inheritance is completely supported in Python. In Microsoft C#, multiple inheritances are not supported. In PHP, it's not supported. In Java, multiple inheritances not supported. You can maximum inherit from a single class. You cannot simultaneously inherit properties of two classes or attributes of two classes. Here you can see we are inheriting attributes of two classes. We're using C to call the properties of class A, which is feature 1, to call the properties of class B, which is feature 3, and to call its own properties. So now this is where it is possible. So now multiple inheritance. If you get this question tomorrow, is multiple inheritance supported in let's say about in Python? So you'll have to say, yeah, hey, yeah, it's supported, right? So now why do we require it? Right? Why do we require it? For example, if we have to create a model, I've already shown you the model design, right? For example, I have a class, let's say about, I have a class login, right? So it has let's say about a constructor. So let me create init. So I'll say define init as self. It does not take any arguments. So it has self dot let's say about self dot name, right, blank. So I'm declaring it. It's just declaration self dot password, self dot username, and it has self dot password, and it may have what, getters and setters of the same. As I have already told you about getters and setters, accessors and mutators, right? And I can create accessors and mutators. So I'll say define. Hey, I want to define. It may take a bit. It may take a while, right? Explaining this. Do we have time? Yeah, we have most probably 5 minutes. So 5 minutes would not be sufficient. I'll show you this in the next class. But yeah, before moving, I'll just give you the hint what is coming up in the next class also. So for example, now we have another class which is register. right? register. So this is the class which is register, right? So now we have a problem here. As long as memory management is concerned, as long as code management is concerned, now first you register. We know that if you go to Facebook, if you go to Gmail or any other website, you provide your credentials and you register first, right? When you provide your credentials, you register, only then you'll be able to log in, right? So you have to sign up. In order to sign in, you have to sign up. Is that correct? So now sign up may require these things. So I'll say self dot, say maybe they may ask you about first name, right? So this is what it's going to be. And then they may ask you about last name, right? So absolute first name, then we have last name, and then they may ask you about your email, right? Okay. So then they may ask you about your, what else? Maybe contact, right? And self dot. So you may have to confirm the password, or you know that you get this quite often, that you need to retype your password in order to confirm your password. It's one and the same thing. So now you are ready. Two classes. You have a login class and you have a register class. Now if I have to register, I will call the register class. So I'll call the register class, right? But hey, wait a second, we have a problem in here. The problem here is, why are you not utilizing the resources? You can clearly see that there is duplicacy of data, which is crime in object-oriented programming. In object-oriented programming, you should not have duplicacy, and you should not have code repetition. Is the most sophisticated word that we can use for programming. Code repetition is a crime in object-oriented programming, right? How do you cope up with this, right? Self.username and password is in login also. Why? Because you require, only when you choose the username and password will you be able to provide the username and password after signing in it. That's absolutely right. But yeah, how? Why is it, you'll say, hey sir, yeah, but we require, username and password in the login class. We also require it here. I'll say, yeah, we can require it, but what if we don't have it here, right? And what if I make this register inherit from login? Here you are saving the code. This is called object-oriented programming, and this is the magic of object-oriented programming, that we are inheriting username and password from login. No need to define it again here. Now if I create an object, I'll say reg, which is register, is equivalent to register. So I'll say register, and can I say reg dot? Now you can clearly see reg dot. I can say reg dot username is equivalent to Fahim. Alright, I can say reg dot password is equivalent to password. Right? So now register is an reg is an instance or an object name of register. Is it true? Yup, it is true. Right? But does register have a property username? No, it does not have. Where is this property coming from? You'll say this property is being inherited by the register class from the login class. I hope I am clear enough. Right? So this is where inheritance is very useful, right? So this was a practical, and this is basically a live example to make you guys understand. Now, how do you define it? If someone comes up and asks you, what is inheritance, right? How will you answer, right? What is inheritance? And not only inheritance in Python, right? We've just seen that it also supports multiple inheritances, right? So now you'll answer, Python inheritances allow us to define a class that inherits all the methods, not only properties. We are just inheriting properties here. Self.username is a property, and self.password is a property of login class. That's what we are inheriting. That doesn't mean that we cannot inherit methods. Yes, we can even inherit methods, right? So you'll say Python inheritance allows us to define a class that inherits all the methods and properties from another class, right? Parent class is the class being inherited from, right? Parent class, the class being inherited from, that means login becomes the parent class, right? Also the called base class, it also becomes the called class or the base class, and this becomes the child class. Child class is the class that inherits from other class, also known as derived class. So this can be called as derived class. This can also be called as called class, or sorry, child class. So this can either be child class and this can either be a derived class, because it's inheriting from the another class. And what it can be, right? So this can be a parent class, or you can say it is a base class, right? It's also known as, it's basically base class, and you can call it as parent class. So I hope inheritance is clear, right? And it's a very powerful feature in object-oriented programming. It refers to defining a new class with little or no modifications in the existing class. Isn't it the magic? Right? Inheritance is capable of one class to deliver and that too Python supports multiple inheritances, right? So you will see that in the near future, once we go and start developing software, that this kind of inheritance is a real magic, and that too multiple inheritances supported in Python is again a bigger magic, right? So I wish you all the very best. Do practice very hard. Let me know down in the comment section if you require any help and if you're having any confusion regarding inheritance and class inside classes, right? So we have seen two things today. We have seen base subclass and a main class inside a single class, and we have also seen inheritance. And out of two, this is something that we are going to be using, we will use that quite often, right, in programming. So this most frequently used thing, which is inheritance. So this most frequently used in object-oriented programming. So guys, all the best, and do practice, do pray for me, and be in sync with me. Complete your work. Don't let on tomorrow what is being assigned to you today. Complete the assignments today and be ready for bigger things tomorrow. And congratulations for coming so far, right? I wish you all the best. Bye bye, take care.